All right, so this week's lesson is going to be on area of polygons, okay? So we're going to have to throw back to some trig, okay? Just a little warning, so just a little reminder, SOHCAHTOA, SOHCAHTOA. So if you want to pause the video and just kind of review what that means and what all those mean, but I'll review real quick with you. So SOHCAHTOA, basically the sine of whatever angle we're looking at equals my opposite over my hypotenuse. Cosine of theta, which is whatever angle we're looking at, equals the adjacent over hypotenuse. And then for tangent of whatever angle we're looking at, so theta is equal to opposite over adjacent. So when we're looking at this, this is only for right triangles, so we're going to be just dealing with right triangles. Sorry, I apologize about my terrible looking triangle, but let's say this is theta, and we could be saying this is theta or this is theta, but let's just say this one's theta. My hypotenuse is always across from my right angle, my opposite is opposite of that angle, and my adjacent is next to that angle. Okay, so just a little SOHCAHTOA review. We won't need that right off the bat, but just kind of a little reminder about that. Okay, so let's look at this first example. Area of regular polygons. So the formula for this is A is equal to 1/2. This is called the apotheum. Okay, new vocab word. Apotheum is A, and then times your perimeter, which that shouldn't be something that we need to review. But basically, the perimeter is the distance around whatever shape I'm looking at. So this is real easy to find the perimeter. So let's find the perimeter, and then we'll talk about what an apotheum is. Okay, but the perimeter would be, this is 8, and we need to count how many sides I have. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 sides. So I'm going to do 8 times 9, which is 72. Okay, so that's one of the things we need. And then the apotheum, okay, is already given to us. Okay, so the apotheum is 11. So an apotheum basically is just a line. It kind of looks similar to like a radius for a circle, but notice how the line is going perpendicular to the side, to one of the sides. It's not going to a corner. Okay, it's going to the side. And also a cool fact is that it's in the middle for a regular polygon, in the middle of this side. Okay, so a couple of things. So that's what an apotheum is. So this is my A, or apotheum. So A is equal to 11. So we have both of the things we need to find our area. So let's just plug it in. Just get my camera down. A is equal to my apotheum times my perimeter. Oh, sorry, 1/2. Big part. 1/2 times my apotheum times my perimeter. Okay, so we'll put that in our calculator. Go and put that in your calculator, and we should get 396. Okay, and if we had units, we'd put whatever units there are squared because we're finding area. All right, so this is where we're gonna have to use our SOHCAHTOA. So, but first, let's just kind of talk about what we need to use that. So, looking at this example, I can create, taking the center of this polygon, I can take the center and I can create a bunch of little triangles. Equilateral triangles. Okay, because this is a regular polygon, so all these sides are equal. Okay, so what I can do also is I can split each of these in half, and this is my apotheum. Okay, so when I do that, okay, I can find what this can be, and then I can also find what this is, my apotheum is, by figuring out what this angle is. Okay, but let's find this side first. Remember I said the apotheum, if we're kind of looking over here a little bit, the apotheum goes right down the middle of this side. So I can find this length right here by taking 1/2 of 7. So 1/2 of 7 is 3.5. So if this is 3.5 and I know the measurement of this angle, then I can find A using SOHCAHTOA. Okay, but how do I find the central angle? So we're going to use our knowledge about regular polygons and about central angles and things like that to figure out what these are. So since this whole distance around here, angle-wise, always is 360. Sorry, that was a terrible circle. But all the way around here is 360. So if I perfectly divide this into each section, right, when I've made those first triangles, right, that's just however many sides I have. So if we count 1, 2, 3, 4, 5, I have 5 angles here. So if I divide that, I should get, let's see, 360 divided by 5, which is equal to 72, okay? But 72 gives me this whole angle right here, okay? So if I'm trying to find this little angle, basically what I'm going to do, or this angle right here, right? This whole thing is 72. So I can find part of this angle by dividing 72 in half. Again, so I do 72 divided by 2, and I get 36. Okay, and we'll learn in a second that this follows the same formula. Basically, it's however many sides you have, or 360 divided by how many sides you have times 2 will always give you this angle, which we're going to use a lot. Okay, so let's look at this. So we know this is 36. So we know 36 goes in here. All right, and then we know that this is going to be my opposite side. This is my hypotenuse, and this is my adjacent. Oh, that's kind of cool how the apotheum is A. That's nice. Okay, so we'll set it up. We know this side, and we're trying to find A, so we're going to use O over A, or opposite over adjacent. So we look at these. Okay, tangent is my opposite over adjacent. The angle I'm going to use is 36. And then opposite over adjacent is 3.5 all over my A. Okay, and then to solve for A, we have to multiply by A. Hopefully you guys remember this from when we did trig. And then we'll divide by tangent at 36. So when you're dividing this out, you must be careful. And if you have, you know, a scientific calculator, hopefully it's already in degrees. But on like the quiz you're going to take, you got to make sure you switch it to degrees before you do this, because it will totally mess you up. So make sure your calculator is in degrees. Usually you just have to press a little button. And I'm actually, let me see if I can actually pull that up for you real quick. Yeah, so I'm going to take this camera off real quick and show you on the quiz what that's going to look like to switch it. So here is my computer, and so normally you would be taking your quiz or whatever, and you go down here to calculator. So make sure when you go to calculator that you switch. See, it's automatically in radians, so make sure you hit this button and switch it to degrees before you do any problems. Big deal, y'all. Please make sure you do that, okay? Then you can work out using that calculator. So let me see if I can put this thing back on.